Good morning to all. Today the topic of the class is components of DBMS. So DBMS have several components and every component play a very important role. So the major components are hardware, software, data, procedures, database, access language and users. These are some of the components of DBMS. We have some components of DBMS, like we have a hardware, we have a software, we have a data, then procedures, then database, access language, and the last component of the DBMS is users. You see the diagram of components of DBMS. First, we have a software, then we have a hardware, then we have a data, and these are the procedures, database, access language, and the last component of the DBMS is user. Now we are going to study all the components in the detail. What is hardware, what is software, what is database, access language, what is data, what is procedures, and how many types of users we have. Now the first component of the DBMS is hardware. So when we think about hardware and when we talk about hardware, we mean computer, we mean hard disk, we mean I/O channels for data, and any other physical component of the computer system is known as hardware. The part of the component that we can see, that we can touch, is known as hardware. So when we run Oracle or MySQL, both are the softwares for executing the commands. So when we run Oracle or MySQL on our personal computer, then our computer's hard disk and keyboard, with the help of which we are typing the commands. So hard disk, keyboard, or RAM, ROM, all become the part of DBMS hardware. So first component of the DBMS is hardware. Hardware means those parts of the computer that you can see, that we can touch. So in case of a DBMS component, we are talking about hardware. So it means your computer, hard disk, its keyboard, RAM, ROM, all are become the part of DBMS hardware. Next component of the DBMS is software. This is the main component. Basically, software is known as the set of instructions. So this is the main component and this is the program which control everything. The DBMS software is more like a wrapper around the physical database, which provide us with an easy to use interface to store, access and update data. So DBMS software is capable of understanding the database access languages and it interprets it into the actual database commands to execute them on database. So DBMS software is the program. By using this program, we can convert our database access languages into the actual database commands that we want to execute. If I want to create a table, I have to follow the syntax of create table command. If I want to delete some table or I want to delete some values from the table, I just need first to write down the syntax, and only that syntax is understood by the SQL. Next, we have a data component of DBMS. And we all know that data means raw facts and figures that are not meaningful. When they are converted into information, then they will become meaningful. So data is data resource for which the DBMS was designed. Let us suppose that we are creating a table. It means we are creating table for some value. It means we are going to insert the value into the table. So data means the facts, the information that we are going to insert into the table. For example, when I store my name in the database, the DBMS will store when the name was stored in the database. Let us suppose that I want to store my name in the database. First, I have to create the table and we should show that that table have the column named as name. Then we are able to insert the value into that particular column. We have one term that is known as metadata. Metadata means data about data. Metadata is also known as data dictionary. It is also known as data repository, which contain the entire detail of the table, like name of the table, size of the table, the number of fields we are using on the table, the number of constraints we are using for such table. entire detail of the table is completely stored in a metadata. The next component of the DBMS is procedures. Procedures means some instructions that we have to follow when we are dealing with database management system. It means we have some instructions, we have some guidelines, we have some procedures that we have to follow when how to set up and install the DBMS, who are authorized to log in and log out of the DBMS software, how can we manage the database, how can we take the backup of database and tables, what we have to do when we have to face for the failures, and how can we generate the reports. All such should be done via some procedure, via some instructions. The next component is database access language. So in this, we have to deal with all the SQL commands like data manipulation languages, data control languages, data definition languages, transaction control languages. So if I want to create a table, I just need to follow some procedures. First, I need to write down the syntax. Then we are able to create a table. It's not an easy task to create the table directly. First, I have database access languages. Then what I want to do, it should be converted into the form that should be understandable by the Oracle. Next, we have the users. We have our database administrator. We have discussed in the yesterday class about DBA. DBA is the person that is known as database administrator, and it is responsible for the overall control of database. It takes care of the security of the DBMS availability, and it is responsible for the overall management of the database. Next, we have application programmer or software developers. This user group is involved in developing and designing the parts of DBMS. Next, we have our end user. End users are those users which are only using the DBMS software. Let us suppose that I am creating a table, I am updating the table, I am deleting the values, I am selecting the values. We are the end user. We are not developing the software. We are not the DBA. We are the end users that are only using the services provided by DBA, or we are simply using the DBMS software for our own requirement. Next heading is DBMS database models. So we have 4 types of model that we have to discuss. That is, first one is hierarchical model, network model, ER model. It's also known as entity relationship model and relational model. Basically, these models are used to define how the data will be stored and how can we access the data and how can we update the data in the database management system. So basically, these 4 methods are used to store the data, they are used to access the data, and they are used to update the data in the database management system. Now we are going to discuss it one by one. So the first model is hierarchical model. In this model, we have to organize the data in the tree-like structure. So we have a single root and other data nodes are linked with each other. Now see it first. This is the parent node, that is college. Now college is divided into 2 categories. First we have a department, then we have an infrastructure. Now we have 3 types of department like a course, then teachers, then students. Now course is again divided into theory classes or labs. So it means that now we are storing the data, we are storing the values into the DBMS, but in the form of tree-like structure. First we have a root node, then we have a child node. Again, department is the root node for course, teachers and students. Again, course is the parent node for theory and labs. So in this model, child node will only have a single parent node. So every child node have only single parent. Like department and infrastructure, both are the child nodes having only single parent, that is college. Course, teachers, students, these are the 3 child and they have only one single parent node, that is department. Theory and labs, both are the child node having only single parent node, that is course. This model describes many real-world relationships like index of book. For a index of book and for other purposes, we can go for this model. In this model, the data is organized into tree-like structure and every node has a one-to-many relationship. like maybe it is possible that one parent have more than one child. So college is the parent node. It has two children, department and infrastructure. Department parent node have three children, course, teachers, students. So it represents one to many relationship, one to many relationship. Again, course is the one parent node having many relationship. It has a relationship with the third child node and a lab child node. So now we have some advantages of using this model. A user can retrieve the data very quickly due to the presence of links between the table structure. So this is the simplest model because we can clearly see who is the parent node, who is the child node, and how they are connected with each other. The referential integrity, it's also known as a foreign key relationship. It means there is a parent-child relationship. There is a one parent node and having a multiple child node. So this is one of the simplest model. In this model, the data is represented in the form of parent-child relationship. So every child node has only a single parent node, but a one parent node have a multiple child. So it's easy to understand which child node is connected with which parent node and which parent node is connected with which child node. It has some disadvantages. When the user need to store a record in the child table that is currently unrelated to any other record in the parent table, it gets difficulty in recording and user must record an additional entry in the parent table. So as we know that every child node is dependent upon the parent node, but if we want to add some values into the child node, it is not possible. First, we have to maintain the integrity with the parent node, then we are able to add any value into the child node. And as I have already told you, it is used for a simple working, so it can't support complex relationship. So when we try to implement such type of models for complex queries, for complex command, for complex relationship, it starts creating problems. The next type of model that we have is the network model. It is the extension of hierarchical model, and in this type of model, the data is organized in the form of graph. Now it is not in the form of tree-like structure, it is represented in the form of graph and are allowed to have more than one parent node. In a hierarchical model, it's just like in the tree-like structure, and every child node has only a single parent node. But in this case, in the network model, every child node has more than one parent node. This model is the extension of hierarchical model, and in this model, we have to present the data in the form of graph, not in the form of tree-like structure. And as we have already studied in the hierarchical model, every child is connected with only single parent node. But in case of network model, every child is connected with more than one parent node. Now see, it is represented in the form of graph-like structure. We have a A. This is the parent node having two child node B1, B2. Again, we have a two child node C1, C2. Now see, the node C2 have, now it is connected with two parents. C2 is the child of two parent node B1 and B2, but that is not possible in the case of hierarchical model. In hierarchical model, every child node is connected with only single parent node. But in case of network model, it is possible that every single node, every child node has more than one parent. Now the node C2 have two parents. One is B1 and the second parent is B2. This is the main difference between hierarchical and network model. This was the most widely used database model. So this model is also used for many-to-many relationships. As we studied in hierarchical model, in case of hierarchical model, we have a one-to-many relationship. One parent have many children, but in case of this, we are supporting many-to-many relationship. It has some advantages. It is the fast data access. So it is one of the good model. It provides fast data storage speed, access speed. So we can use it for a complex relationship as it's stored many-to-many relationship, not one-to-many, many-to-many. That's why we can use it for complex relationships. It has some disadvantages. It's a complex data model. So The user must be very familiar with the overall structure of database, otherwise you are not able to work with this model. So it's sometimes updating the inside this database is difficult and boring task because it's so complex relationship. So updating many to many relationship is not an easy task. If you don't have the deep knowledge of this structure, you are not able to do anything. Next, we have a ER model, that is known as entity relationship model. In this model, we have entity and its associated attributes, and we just need to show the relationship of entities along with its attributes. Now see, in this diagram, student is the entity. Entity is the person, a place, or a thing that we can see. Student is an entity and it has some attributes. Address is the attribute, age is the attribute of the student, ID is the attribute of the student, name is the attribute of the student. As we know that every student has address, every student have a age, every student have a ID, every student have a name. So student is the entity and these ovals represent the attributes. So this is the entity relationship diagram. It shows the relationship among the entity along with its attributes. ER model are used to represent the relationship into the pictorial form. We can use this model to show the relationship between the entities and attributes in the diagrammatic nature. This model is good to design a database. It's a very good model to design a database because it defines a clear picture of what we are doing. Let's take an example. If we have to design a school database, then the student will be an entity because we know that every school and every college has the main entity that named as a student. And every student, no matter a student is in a college or student is in a school, every student have a name, every student have a age, every student have an address. Again, we split the address into street name, pin code, city. So entity relationship model is one of the model to store the data into the database. But in this model, we have one entity that is known as student. It may be any other entity. So every entity have attributes like name, like address, like age, like ID. So we have some advantages of using this model. The first is conceptually it is very simple. So this model is very simple to understand as compared to hierarchical model, as compared to network model. Next is better visual representation. As we know that we have to draw the entities and relationship of entity with attributes. So it provides a good visual representation of entities and its relationship among their attributes. It's a good communication tool. It's a good technique for database designers. So it's a highly integrated with relational model. Its ER model can be easily converted into relational model. We can convert or we can migrate it into some other models in a very easy manner. Easy conversion to any other model if we are designing the ER model and later on I just want to convert it into relational model or hierarchical model or network model, it's very easy to convert ER model. We have some disadvantages of using this model. First is loss of information content. We have to face some problems of loss of information content if we are using ER model. We are only limited to some relationships. We are not able to show the all relationship. We are bounded to show the limited relationship. No representation of data manipulations. It's very difficult to show the updations and changes we are doing in this model. And basically, this model is very popular for high-level designs because in this model we can represent the information between the entities and their attributes. The next model is relational model. In this model, the data is designed and organized in two-dimensional tables. Now we have to represent the data in the form of tables, that is in the form of rows and columns. the basic structure of data that we are going to store in the relational model is in the form of tables only. We have to store the data into rows and columns. So table are known as relation in relational model. So in relational model, we are storing the data in the form of tables, and we know that table is the combination of rows and columns. Now see, we have student ID, then name, then age, then subject ID, then name, then teacher, then we have student ID, subject ID, and marks. It means this diagram shows that if we are storing the data in the relational model, we have to follow the table structure. Then we have a column, we have a columns, then we have a rows, and this is the column names, this is the rows information. So if we are using relational model, we have to store the data in the form of tables only. It means we are storing the data in the form of rows and columns. We are not able to follow the tree-like structure. We are not able to follow the entity relationship. We are not able to follow the graph-like structure. We have to store the data in the form of tables only if we are going for relational model. We have some advantages of using this model. First is simplicity. It's a very easy and simple model. We are storing the data in the form of rows and columns. Structural independence. It means every row is independent of second one. So there is no dependency. It's very easy to use. It's very easy to use the rows and columns. Query capability. It make it very easy and possible for high level query languages like SQL to avoid complex database navigation. Everything is stored in the table. We can easily search by row ID or by column ID. So data independence is there. So we can change one row, one column without affecting the second one. Scalable. Scalable means we can add more rows and columns according to the requirement. Next, we have some disadvantages of using this model. We are limited enough on the size, or we are limited enough on the limits on the field length. We have to follow some specific field length. We cannot go beyond this. Sometimes it becomes complex as the amount of data grows. If you are going to store the 50,000 values into the table, sometimes it creates a problem. Complex relational database system may lead to isolated database where the information cannot be shared from one system to another. So if we are going for complex relational database, we are not able to share the information from one system to another. It becomes isolated. It cannot be shared among any other model or any other system. Thank you so much, class.